All right, guys. So today we're going to be talking about 3.2b systems by elimination. Yesterday we really did 3.2a, talking about systems by substitution. And so you notice right off the bat the format that these are in. And I said before that depending on what kind of format these equations are given to you, kind of determines what's the kind of the best method to use. And really, that's a matter of preference. But again, sometimes equations just lend themselves better to one method or another. So, what I want you to notice about these right off the bat, number one, is that they are written in standard form. Both equations are written in standard form. So, if you notice, I have my x values in this column, if you want to call that a column, the y values in this column, and then I have some constants over here. So it's kind of everything's kind of lined up, if you will. You remember from grade school when you had to line everything up to make sure, especially when you were adding or subtracting decimals, to make sure that everything was in its proper spot. Well, in this case, both of these equations are kind of lined up. So when it's that way, it really does lend itself to elimination. And so if we look at this, I want you to notice, and what you're really looking for is you're looking for common coefficients. So if you notice here, my coefficient of the x values is -6 and 9. The constant that's out here doesn't really matter. They're 12 and -18. But what I want you to notice here is the coefficients on the y's. Both of those coefficients are actually a 1. When you have a common coefficient like that, then again, it's kind of a best case scenario. You've got both equations in standard form, and you've got one coefficient that's already the same. Then that really lends itself to elimination. This can be a very quick method. I think that's why I like it a lot better than any of the other methods for solving systems. But the first thing you're going to do is think, okay, there's a reason it's called elimination. So the reason it's called elimination is you're trying to eliminate at least one variable so that you can solve for the other variable. It's a lot like we did with substitution, how when you substituted in, you either ended up with all x's or all y's in your equation. Well, that's kind of what you're shooting for here, but it's just a little bit easier in my opinion. So the first question we have to ask ourselves is, if we were going to add these two values, would we add or subtract in order to eliminate? Well, if I take +1 plus a -1, then that is going to cancel out, okay? If I were to take +1 minus a -1, I'm actually going to end up with 1. Again, keep, change. I'm going to end up with 1 plus 1, which equals 2. Well, that's not going to help me. So I don't need to subtract the -2. I need to add the -2. So what we're going to do is the same thing Miss Nolan taught you to do once before, and that is to put you a little plus sign right here to indicate that that is the operation that we're going to do, and we're going to add these two equations together. So what I'm going to end up with is -6x plus 9x. Well, let's think about what that gives us. -6x plus 9x would give me a positive 3x, okay? Here, these two things, that's the whole reason we added. These two things are going to go away. They're going to be eliminated. So that's the reason it's called systems by elimination. So those are eliminated, and now I'm left with 12 plus, and that's the reason I put this over here so that I'm reminded of what operation I'm doing. 12 plus a -18 is going to give me a -6. And so if I go ahead and finish and solve this, I'm going to just divide by 3. And really quickly, you notice I get x equals -2, okay? Very quickly, I get my answer that I need. Now, here's what I have to do now. Now I have to go ahead and solve this equation for the y, okay? So I'm going to take this -2, and I can put it into either one of these that I want to, okay? So I'm just going to put it in the top one. And the original equation we had was -6x plus y equals 12, okay? So all I literally have to do is to put this -2 in for this x right here. So I'm going to have -6 times -2 plus y equals 12, okay? And if I go ahead and finish that out, I'm going to get a positive 12 right here plus y equals 12. And to finish, I'm going to do -12 on both sides, which is both going to cancel. Oh no, what happened? Well, remember, what is 12 minus 12? Well, 12 minus 12 equals 0. And guys, it is all right to get an answer of 0. Sometimes we get scared and we think that cannot possibly be right. But that is absolutely right in this case. So the ordered pair that's going to be our answer here is going to be -2 and 0. Okay, that would be the answer for our first system. Now, in this case, we used addition in order to eliminate. So let's look at the second case. The second case, again, I'm still in standard form and I'm looking for common coefficients. Well, right away, I see common coefficients right here. I see -7 in front of both of these y's. So then my question is this: do I need to subtract or do I need to add? Well, if I add -7 plus -7, that's going to equal -14. Well, that's not what I need. I'm trying to eliminate, so I'm trying to make that equal 0. What if I take -7 minus a -7? Well, again, think about what happens here. We're going to keep, change, change. And so -7 plus 7 does in fact equal 0, and that's exactly what I need. And so in this case, I need to subtract everything here. Okay, because if I do it to one term, I have to do it to everything. So now let's go ahead. We're going to use subtraction everywhere. So this is something that you really got to think about adding and subtracting integers. So I have -9 minus a -2. If you need to write that out to the side, then that's fine. -9 minus a -2. And if you need to go ahead and do keep, change, change, then do that as well. Obviously, if you've got a calculator, you can go ahead and put that in exactly the way it is. So -9 plus -9 plus 2 is -7. So I'm going to end up with -7x. Okay, this is going to cancel. That's the whole reason we did what we did. And then we have -14 minus a -14. -14 minus a -14. So again, keep, change, change. -14 plus 14 equals 0. Which means now I still need to get rid of this -7, which means I need to divide by -7 on both sides. And what is 0 divided by -7? That gives me 0. So in this case, x equals 0. And again, that's okay to get an answer of 0. That will happen from time to time, okay? Now I have to substitute back in to one of these two equations in order to solve for y. This time I'm going to use the second one just to show you that you can do it in either one, okay? So -2x minus 7y equals -14 was our original equation. So I'm going to go ahead and put the 0 in. This is my answer for x. I'm going to put this 0 in wherever I see x, okay? -2 times 0 minus 7y equals -14. Well, what's going to happen with -2 times 0? -2 times 0 is 0, so it's just going to go away. So I'm going to go ahead and mark it out. And now the only thing I'm left with is -7y equals -14. So I just simply divide by -7 on both sides. And so y equals negative divided by negative is positive. 14 divided by 7 is 2. So there is my solution now for this particular system is going to be 0 and 2. So a little bit different than the solution we had up there. 0 and 2 is going to be our solution. So now let's look at number 3. And we only got 2 more of these to go, so just bear with me. Number 3, if you notice here, I do have everything in standard form. The problem is I do not have common coefficients, okay? And this is going to be something that you're going to have to be able to work through. So if you notice, I have a -5 and a 1 here. I have a 5 and a -3 here, and then I have 15 and 3, which are my coefficients. Doesn't really matter anyway, because I've got to eliminate one of these two variables. Well, what could I do to either one of these equations to make it have the same coefficient as the other? Well, I think probably the easiest answer is that I could multiply this whole equation here by 5, and I would have this common coefficient right here, okay? So here's the thing. You can multiply this 5 times everything, and it doesn't really change the problem. It helps us, but it doesn't change the problem because all I'm doing is I'm just magnifying this amount by 5. So I'm making it much, much bigger. But the key is I have to multiply by every term. I can't just multiply by one term. And so this literally becomes a problem where I just distribute this 5 through everything. And so 5 times x becomes 5x. 5 times negative 3 becomes negative 15y. And 5 times 3 becomes 15. So now my two equations that I'm really focused on is I'm focused on this one and I'm focused on this one. I'm not even really worried about the middle one now because this one really is equivalent to that one. It's just 5 times bigger, okay, if that makes sense. So now I'm looking again, I've got my common coefficients, which is what I was going for the whole time. And now do I need to use addition or subtraction? Well, if I take negative 5 plus 5, that is going to give me a 0. So that's exactly what I need to do. I need to add these two equations. So I'm going to put my addition symbol and I'm going to start working through. Negative 5x plus 5x goes away. It's gone. Now I've got 5y plus negative 15y. 5y plus negative 15y is going to equal negative 10y. And 15 plus 15 is going to equal 30. So very quickly you can see I got to an answer here to where I can divide by negative 10 and I'm going to get an answer of y equals negative 3. Now in order to solve for x, I can literally put it back into any one of these equations that I want to. And if you think about it, which is going to be the easiest one to put it back into? Well, this one that we originally started with. Yes, we can even use the one we originally started with. So I'm going to put in x minus 3y equals 3. I'm going to go ahead and put this negative 3 in right here for this y. So I get x minus 3 times negative 3 equals 3. So I'm going to get x plus 9 equals 3. And if I subtract the 9 from both sides, I'm going to end up getting x equals negative 6. Okay? So again, what are my answers here? My answers are, remember, this one will go first because it's the x term. X is negative 6, and my y term is negative 3. So that would be my solution for that particular system. Last but certainly not least, we have this guy right here, number 4. And if you look at number 4, you notice that we have very similar equations, okay? Very similar equations. So we have those in standard form, but you note that my coefficients are the same on both of these, okay? So really we can work with either one we want to. We can work with the 5 and the x terms, or we can work with the 10. It doesn't really matter which one. But the first thing I need to decide is what kind of operation am I going to use, addition or subtraction? Well, 5 plus a negative 5 would in fact give me a 0. So why not? We'll use that one. We'll use addition. So I'm going to add. If I have 5x plus negative 5x, if I had $5 and somebody took that $5 away, I no longer have any money, so that becomes 0. Now let's think about this one. If I have negative 10y's and I add positive 10y's to it, where am I going to end up? Well, I'm also going to end up at 0. So now I have 0 plus 0, which is basically 0. And here I have negative 90, plus 30, which is going to equal negative 60. So my question to you is this: does 0 equal negative 60? Well, of course not. 0 and negative 60 are totally different. They do not equal. And so because I come up with a solution that does not equal, that means that this is a no solution. In other words, those two lines are never going to cross one another. If I look at this graphically, those two lines are never going to cross, and so there's never going to be a place where there's going to be a solution. So that would be no solution for that particular question. And you will have a couple of those on this assignment as well. You will have some word application problems, which I know that you guys love. But again, those should be pretty easy. They shouldn't be too bad. And obviously, if you need help or have any questions, again, feel free to get in touch with me or Miss Willard, and we'll be glad to help you the best we possibly can. Thanks.